Hi there, Mr. Sutton here, bringing you the Pre-Cal Honors 3-7 Extra Practice Number 1 solutions on graphing rational functions. For this problem, they want us to sketch this rational function, and they've given us most of the essential stuff here. So we're going to go ahead and use this now to put this all on a graph. So starting with the points, there's no x-intercept, so we don't have to worry about that. There's a y-intercept of -1/3, so that's going to be down about here. Next, we have a vertical asymptote at x equals 1. So that's a vertical dashed line going through x equals 1, like so. And we've got a hole at -2, x equals -2, but we can't really put that on there until we either plug it into the simplified function or just wait to see where the graph is and stick it on the graph after the fact. We do have a horizontal asymptote at y equals 0, though, on the x-axis, so we can draw that in. Now, looking at the graph, I see that I've got a point on the left side of this vertical asymptote, so I know that my branch is going to be going in the lower left here, but I'm not sure if I'm going in the upper right or the lower right on the other side. So I needed an additional point on the right side of that vertical asymptote to figure out where my graph is. So I'm thinking the point where x equals 2 would be a good one to use. So let me plug 2 into this function, and I'm going to use the simplified function here. I'm allowed to do that since I know that I have a hole that's not at x equals 2. So using the simplified function won't give me any weirdness. So let me go ahead then, and if I plug that in, I've got 1 over 6 minus 3, so 1 over 3. So that's the point 2, comma 1/3, right about there. And at this point, I can draw my branches in. So I've got one branch going through this lower left point, hugging the asymptotes, but not touching them, right? Getting as close as I can without touching them. Same kind of deal up in the upper right, going through this point and approaching the asymptotes. And we can't forget, we do have that hole at x equals -2. So at x equals -2, the graph is right here. I'll just put the hole right on the graph itself at x equals -2, and then I'm good. For this problem, we're trying to sketch the graph of this rational function, which they've given us the original and a simplified version, and also the key features of this graph. So going through and using the features, we've got a y-intercept at -3, so let me put that on the graph right here at -3. Vertical asymptote at x equals 1, so that's a vertical line going through x equals 1 right there. And there's a hole at x equals 2. We'll worry about that after we've actually got the graph. We'll just stick it on the graph kind of after we've done everything else. Horizontal asymptote at y equals 0. So that's on the x-axis. You can redraw it, but you don't have to because the x-axis is kind of an asymptote if you don't draw anything there. All right. So at this point, I noticed that I don't have any points on the right side of the vertical asymptote. So I'm not really sure if I should be graphing in the upper right or the lower right. So I'm going to need an additional point over there. Now, normally, I would just use the x value that's like 1 to the right of the vertical asymptote, so an x value of 2. This problem's a little unique, though, because there happens to be a hole at x equals 2. So although I could plug 2 into this reduced function here, I know 2 is going to make the original function undefined because there's a hole there. I could plug it into the reduced function and get a y value back, but then that just feels kind of weird putting an open dot that I then put the graph through. I mean, I could do it. It just feels weird, though. I want a point that actually exists on the original function. So I'm actually going to plug in the x value 3. That should give me something else that I can use. So plugging in 3 then, I've got 3 over 3 minus 1, which is 3/2. So I've got the point 3, comma 3/2, 1.5 right here. So now let me draw a branch going through this point and hugging those asymptotes. Let me draw another branch going through this point and approaching the asymptotes. And now my hole at x equals 2 that was causing me trouble earlier, I'll just put it right on the graph, right at x equals 2, right there, and then this one's finished. For this problem, before we go ahead and try to find intercepts, asymptotes, and graph this thing, we should try simplifying this a little bit, maybe try factoring it. So let's see here. In the numerator, I think I can take a -2 out of everything. That leaves me with x squared plus 1x minus 6. And I can go a little bit further in the numerator, actually. Two numbers that multiply to -6 and add up to 1. That would be x minus 2 and x plus 3 up there. Now the denominator, I've been kind of ignoring it up until now, but it looks like we can factor that too. Two numbers that multiply to -2 and add up to -1. That would be, let's see here, we're going to have x plus 1 and x minus 2. Looks like those x minus 2's cancel. So we've got -2 x plus 3 over x plus 1. All right, so let's work with this now. Let's start with the x-intercepts. Those are going to be things that zero out the simplified numerator. So let's take that numerator up there, set it equal to 0, and we very quickly see that if x equals -3, that's going to zero everything out there. Next, for the y-intercepts, we're going to plug 0 into the original function. If I do that, it looks like everything is zeroing out except for a 12 and a -2. Leaves me with -6 if I reduce that. Now for vertical asymptotes, we're going to set the simplified denominator equal to 0. Anything that makes the simplified fraction undefined gives us a vertical asymptote. So if x plus 1 equals 0, then x equals -1. And then for wholes, those make the original function undefined, but not the simplified function. So they're not as bad as asymptotes. So this canceled out x minus 2. Whatever zeroes that out is going to give us one of those wholes. So that's going to be x equals 2. And we're going to have to remember that when we're graphing it. And then finally, horizontal asymptotes. Looking at the relative degrees of my numerator and denominator, they're both x squared. So we have the same highest exponent, the same degree. So we take the coefficients of those x squareds and look at the ratio of those. That's a -2 over an invisible 1 for my horizontal asymptote. So I can say y equals -2 then for that. All right, let's go ahead and graph this out with the information we have. I'll start with the x-intercept of -3. That's right here. And we have a y-intercept also of -6, so that's down here. Gives us a couple points to anchor our rational functions. Next, we have a vertical asymptote at x equals -1. That's right here. And the whole we'll deal with in a second after we've actually graphed those branches. We're just going to stick it on there kind of after the fact. The horizontal asymptote at y equals -2, that's right here. And do I need any additional points? It doesn't look like it. I've got 1 point on each side of the vertical asymptote, so that's actually enough to graph the whole thing. So on the left, I'm going to graph some branches that approach my asymptotes and go through this x-intercept like so. On the right side, I'm going to go through this point approaching my asymptotes in the lower right here. And then I don't want to forget about the whole at x equals 2. So at x equals 2, I'm just going to go to my graph, whatever part of my graph is at x equals 2, like right here, and just put that open dot right on there, and this one is done. On this problem, we need to find all the intercepts and asymptotes and then sketch the graph. So let's see here. Can't really factor this. I mean, I could factor this, but it's not going to get me much because there's nothing to cancel out. So let's just go ahead and find the intercepts here. So for x-intercepts, I need to set my numerator equal to 0 and solve that to zero out the fraction. And if I add 9 and square root, I have x equals plus or minus 3. Now for y-intercepts, I just need to plug 0 into all the x values. So we've got 0 squared minus 9 over 2 times 0. That's -9 over 0, which is undefined. So it turns out there are no x-intercepts on this one. For vertical asymptotes, I need to zero out the denominator. So 2x equals 0. That means we have a vertical asymptote at x equals 0. For wholes, there are none. We didn't cancel out any common factors, so we're good to go on those. Horizontal asymptotes, this is a top-heavy function. We have a higher degree, x squared, versus x to the first, a higher degree in the numerator. So because we're top-heavy, there is no horizontal asymptote. There is, however, a slant asymptote, which we can find by dividing the numerator by the denominator. Now, since I don't have a binomial in the denominator, since it's just this monomial, 2x, I can just divide each of the terms in the numerator by 2x, and that will give me my slant asymptote. So we've got x squared over 2x minus 9 over 2x. X squared over 2x, got some x's canceling, so it's x over 2, which I can rewrite as 1/2 x. And then for this other term with the 9x down here, it turns out we can just ignore this because slant asymptotes, those occur as you go to the far right or the far left. They really take over. And with really high or really negative x values, this denominator is going to get so big that this whole fraction is going to go to 0. So we can just ignore that last piece there. So 1/2 x is our slant asymptote. Let's go ahead and put some of this on the graph now. So we have negative and positive 3. So we have positive 3 and negative 3 for the x-intercepts. Let's see, no y-intercept. Vertical asymptote at 0, so that's the y-axis. We'll just draw a dashed line just to kind of emphasize the fact. And we have a slant asymptote going through 1/2 x. So that's a y-intercept of 0 for that slant asymptote line. And then from the origin there, we're going up 1 over 2, up 1 over 2, like so. Taking a look at the graph now, it appears that I've got points on either side of the vertical asymptote. So I actually don't need to get any additional points here. I can just go ahead and graph with what I've got. So on the left side, I'm going through this point at negative 3, hugging the asymptotes here, like so. And on the right side, I'm approaching the asymptotes through this point, like so. And then we're all set on this one. There was no holes, so we are done on this.